Okay, fantastic. Thanks for coming. There's a few things on this screen that might be useful. The survey, I've already sort of looked at the results, but if you want to fill that out real quick, it's only 3 questions, and the first 2 are just really to get an idea of kind of who's here. It looks like we have a fair number of experienced teachers based on the first people that filled it out. And then there's a link to the presentation. That's also the link that is on the list of resources on the Math in Action page. So I'm going to go ahead and get started here. As I was practicing, I realized that I have a lot to talk about, so I don't want to waste too much time on the logistics. Like I said, if you didn't fill out the survey, it's really not the end of the world. It's just to give me an idea who's here. So I'll tell you a little bit about myself first. My name is Zach, obviously, and I teach at Mount Pleasant High School. This is my 10th year teaching, and I've taught here my entire career. Mount Pleasant, for those of you that don't know, is kind of right in the middle of the mitten. It's where Central Michigan University is located, and I love it here. I work with fantastic people. I've got fantastic students. I'm sure every teacher says that, but I always tell people I could have moved in the last 10 years and decided not to. So I really love it here. This is my family, my wife Jackie there, and this is my son Maverick on the right. He's 3.5. He's going to be 4 in May, and then my daughter is almost 8. She's going to be 8 in March, so she's got a big birthday coming up. I suppose all birthdays are big birthdays for her. And that's my dog Carson here. The cat is not pictured, but we also have a cat named Sarah. So that's a little bit about me. I've taught mostly calculus, pre-calculus, and algebra 2, but over the years I've taught everything from algebra 1 to credit recovery math to geometry. Although thankfully it's been many years since I've taught geometry. But yeah, so that's a little bit about me. So today I'm going to talk about empowering mathematics, and I want to first thank Math in Action for inviting me to speak or accepting my proposal to talk about empowering mathematics today. And I want to read the description real quick and talk about what I was thinking in the description. The description says, mathematics should empower students. Pulling on my experience designing a math elective called critical thinking, I will define empowerment, show how it differs from social justice education, and propose apolitical methods to develop students into courageous problem solvers. Discussion is encouraged. As I was going through, I realized there's not a ton of time for discussion, so I apologize for that. I'll stay on after the session if you want to talk, or I'll drop into the coffee chat Zoom if you want to talk more. But I appreciate having the opportunity to talk about some of these things and some of these ideas that are maybe not in the popular kind of zeitgeist of education right now. One other disclaimer: as I was practicing this talk, I'm going to be talking in generalities, and I noticed that as I was practicing, I was trying to justify every generality that I would say, and it took forever. So if you think that I'm kind of totally wrong on something where I'm making assumptions about averages or something like that, please stop me and feel free to interject or drop it in the chat, and then I'll certainly address it. But if you think, yeah, that's more or less true, or that's probably more or less true, or that's something that I can kind of ask him later, then then let me go a little bit, okay? So let's get going here. Here's how this here's how my session is going to break up. I want to tell you a little bit of my story and why, and I developed a course called Critical Thinking. This entire day, or this entire session, we will be talking about, we'll all be kind of leading into this elective that I taught for the first time last year, that I taught and designed for the first time last year, called Critical Thinking. And so I'll talk more about what that course is later. But then I want to talk about teaching math these days in the context of teaching math in the United States today. And so we're going to sort of zoom out for a little bit, and we'll get a little bit, we'll wax a little philosophical for a little while. I'm also going to talk in that part about social justice education and what that means for math teachers and what social justice math is, and it will become clear by the end of it that I'm sort of skeptical of these ideas in education. So so that'll be the second part. The third part, I'm going to lay out sort of what I call an apolitical philosophy of empowering mathematics, and I will talk about the ideas that I share with what you might say like proponents of social justice education, the ideas that I think, where we both overlap in our goals, and how their goals can be met via apolitical means and methods. So that'll be the third part. And then hopefully most of the talk will be how I teach critical thinking, what the course looks like, how it achieves the goals that I have for an empowering mathematics philosophy. And then I want to share also things that you can use in your class. So when I developed critical thinking, my thought was, well, I can develop this course and as a math elective, and it could be anything from people, if I do a good job, could take the entire curriculum and propose their own elective and modify it to suit their needs, or all the way down to just single 10-minute or 15-minute activities that people could do to just kind of insert into their math classes at different times. Maybe it's the day before Christmas break and you need something that's maybe not super heavy in content, and so maybe you drop in a little half-hour lesson from the course or something like that. So that's where we're going. That's kind of the outline. Any questions before we get going too far here? All right, so like I said, if at any point you do have questions, feel free to drop them in the chat or stop me and ask. That's totally fine. All right, so I want to tell you a little bit about my story. I want to talk about applying mathematics, minimizing concepts, and missing concepts. And I'm going way back to the beginning of my career, way back to 2011 when I started teaching. There were a few things that I noticed were, I don't know, problems in math education. Of course, there's plenty of them, and some of them are wickedly difficult. But a few that I was focused on early on is applying concepts. So this is my friend Steve Kelly. He was actually my high school math teacher. But we spent a few years working to reinvent pre-calculus and using the flipped model. And what we were really trying, when we started, we were really trying to integrate project-based learning. And so we learned about project-based learning. We looked at different projects for math project-based learning, and we found it was really difficult to find projects that kept that maintained high levels of mathematics in them. So quite often the project would be cool, but the mathematics was quite secondary to the overall project, and in pre-calc especially. We found it really difficult, and since then I've looked at project-based learning stuff, and I always look at it and I think, that's kind of, maybe I'm just not doing it right, maybe I don't understand something, but it seems like the math always gets minimized to some extent. So what we ended up doing is much more of a problem-based learning, inquiry-style learning. We sort of integrated a lot more of those ideas than the application or project-based type learning. I also noticed that we minimized concepts. So again, here's a generality for you. I think that we minimize probability and statistics in our math curriculum on average. At least at my school, we talk about a little bit in Algebra 1, a little bit in Algebra 2, but probability and stats, just to focus on that one, is sort of minimized. And when we do teach it, when we spend time teaching it, we teach it in quite an algorithmic way, right? So we teach the concepts that lend themselves to follow these steps and you'll get your answer. And there's reasons for that, right? It takes time to learn how to think probabilistically and to really understand statistics and data and those kinds of things. But it's nonetheless true, and those are ideas that are important, and there are others as well. But I noticed that we were minimizing concepts that I thought were important. I also noticed that there were concepts that I had learned about that I think are just totally missing from the curriculum. So game theory is a good example. So game theory is a branch of applied mathematics where they use tools for analyzing situations in which there's like different parties called actors, and how they make decisions that are interdependent on each other. And so the fact that they're interdependent leads, with game theory, you can sort of analyze the situation and figure out what are the most logical outcomes based on each player's incentives and those kinds of things. So this is totally missing from the math curriculum and other curriculum as well. There are ideas from game theory you're probably familiar with, the law of diminishing returns, prisoner's dilemma. There's I can't believe I'm totally blanking on it, where there's the tragedy of the commons, where there's the grazing area and the sheep eat too much grass or whatever, tragedy of the commons. Anyway, these ideas do show up in fits and starts in other classes, social studies maybe, and that kind of thing. But anyway, mostly missing. Graph theory. Graph theory is the study of graphs, which are just these simple kind of mathematical structures to represent relationships between different objects. As you can, if you look at that image there and kind of think about like networks and those kinds of things. Plenty of applications of graph theory as well. And graph theory is very accessible to even elementary students. This is not something that I learned about it in college, was my first exposure, but it does not have to be that way. The basic premises are quite accessible for even young children. Formal logic, and I know at this point you are all probably thinking, well, what about geometry? And I think formal logic does get taught in geometry. Again, I'm thinking, how can we take formal logic and really take it to an applied level where we start to look at like not just the symbolic logic, but also talking about like logical fallacies and how you know that a chain of reasoning is incorrect and those kinds of things. The other thing with, again, speaking from my experience, with geometry, I feel like we try to get through the formal logic and proof unit basically as fast as we can. It's just sort of like a car crash on the side of the road. It's like, let's just go by it and try to get through it as fast as we can because it's so painful sometimes. And then also applied statistics, which goes on, along with what we talked about with where I was talking about prob and stats and that kind of getting minimized there. I'll give you a second to read the comments while I take a drink of coffee here. Are there any questions at this point? All right, cool. We'll keep rolling here. Now, this is, so missing concept psychology, and so this is not necessarily to mathematics. I don't expect psychology to be taught in mathematics. That's not what I'm arguing. This is more of a general comment on just education curriculum in general. At Mount Pleasant, we actually do have an abnormal psych and a general psychology elective, but I don't think that's very common in most schools and districts. And so there are so many, over the years, I've just realized that there are so many areas of psychology, just basic, psychology that can be really useful for students, and that students, I think, you can empower them if they know about these ideas, if they know about confirmation bias, if they know about metacognition. Metacognition, this idea of thinking about your thinking, is really a power tool for learning. So, again, that's not necessarily to the math curriculum, but just in general. Okay, so I see these are all things that I kind of am thinking about over the years, and man, it'd be great if we could work this into math somehow and work these ideas into education somehow. And then, the 2016 election happens, and the 2016 election just sort of ends up being, for me, where all of these ideas really become salient, and this idea of empowering students to think effectively, to think clearly, to make sense of the world, to make sense of what's going on. After 2016, I thought, and the other things I'm going to describe here, I thought we really need to think hard about how to help our students make sense of what's going on. So in 2016, we have Donald Trump as elected president. We have this phenomenon of fake news. And so there's actually, there's obviously real fake news that is just completely fabricated, but then we have the president saying that certain news that we thought was actually just news is fake news. And so I'm not making a value judgment on that at all. I don't need to. It's just confusing, right? Like, what is fake news then? And so I'm thinking about this in context of my students and understanding what's going on. We have the rise of white nationalism to some degree, and the alt-right, and that kind of sort of culminates in Charlottesville, and never obviously totally goes away. So we have that. We have people trying to make sense through social media, and I think about trying to make sense through social media and how public it is, and just all the psychological ramifications of that. We have the shouting down of speakers on college campuses, and these are not just some of them are certainly provocateurs like Milo Yiannopoulos and those kinds of people, but then we also have like progressive biology professor Brett Weinstein, a sort of runoff of Evergreen College campus out west. Nicholas Christakis, who's an academic physician at Yale, he is confronted by a mob of students. And you can kind of look these people up and kind of check it out for yourself. So I see this happening, right? And then I see social justice ideology, the idea of diversity, equity, and inclusion, and white fragility. These ideas are on the rise. And all of this stuff, I'm not making value judgments on it. I'm just saying that all of this is landing in my mind, and I'm trying to think of like, how am I making sense of it, and how do I help my students make sense of it? And then some of you are going to be familiar with this. There used to be a conference called Twitter Math Camp, and it was a conference every summer, and it was largely people that were in a Twitter community called the Math Twitter Blogosphere, MTBOS, still active on Twitter. And it was really, I never had the chance to go. It was always far away, but it always seemed like a fantastic conference. And after the 2018 conference, this is my understanding of it, they decided that they were going to make an effort towards getting equity right and prioritize equity for TMC 19 for the following year. This consisted of asking people that were proposing, putting in proposals to speak or to run sessions to have an equity statement. And my understanding of this, and you can look it up to make sure that I'm not wrong or mistaken, but was that there was quite a bit of conflict over how these equity statements should be judged and weighted against each other and weighted in the context of accepting speakers or not. And through that disagreement, they essentially, the end of the story is that TMC 19 was canceled. And so I thought, well, these educators, who I had, at that point I'd been on Twitter for, I don't know, since 2011 in education Twitter, and the MTBOS shortly after that. If these educators, who I think are some of the most progressive educators that I'm aware of, that I know of, can't, quote, get equity right, is there something wrong with the philosophy? So that was a question that I had. We have other things in academia. We have the replication crisis in academia. We have the grievance studies hoax, where James Lindsay, Peter Boghossian, and Helen Pluckrose, who are professors not in critical studies, wrote papers that were accepted into journals in areas that they called grievance studies. This would be cultural studies, queer, race, gender, fat studies, sexuality studies. So these are professors not in these areas of study that are getting papers accepted into journals. One of them, in a feminist geography journal, even won an award. And so again, all of this stuff is landing in my mind. I'm trying to figure out how to make sense of it all. We also had the ideological homogeneity of higher ed, and you can look up data on this as time goes on. Academia has become more and more left-leaning. Again, I'm not making a value judgment here. I'm just saying that these are things that are going on, and we have to think about how to make sense of them. As this, also, I'm learning about different thinking models. I'm learning about things like anti-fragility and anti-fragility. I'm learning about fallacies. I'm learning about the scientific method more deeply and these kinds of things. All of this stuff is kind of, like I said, mapping into my brain. And so that all leads to this, which is the second part of my talk here, which is teaching math these days. Any questions to this point? Okay, so I hope I haven't lost too many of you. So let's talk about teaching math these days and teaching math in context, all right? So I'm going to reference the social justice suite of ideas, which I'm referencing or talking about diversity, equity, inclusion, anti-racism, white fragility, decolonization, all of these ideas that have become more and more popular recently. And I want to say at the outset, again, a disclaimer here, each of these things has a nugget of truth in them to varying degrees. What I'm talking about when any level of criticism here is I'm talking about embracing these ideas wholly and when they're taken too far. And what I really worry about is that the road to too far, that road doesn't have very many exits. That's what I worry about. And I'm open to being wrong, but I'm a little bit worried. So I also don't want to get too deep into the weeds of why I'm skeptical of these ideas. I'm happy to talk later, but we could talk about this for a long time. So I'm just going to sort of give you an overview of kind of where I'm coming from. So hopefully at this point I've demonstrated that I've been thinking a lot about how to help students make sense of the world for years, all right, and how math can kind of play into that. And I think we definitely need to have wide-ranging discussions about how math fits into current events. I'm not going to stand at the spot where we say we just go into our classroom, lock the door, and the outside world, we can totally ignore it. We can probably do that more in math class than other classes. Totally agree with that. But I also do think we need to think about how mathematics can help students make sense of what's going on out in the world. I think we do have a role to play. I also want to point out that if there are structural barriers to different groups of students and kids learning to different levels, then we need to figure out what those structural barriers are, and we need to solve the problems. Always trying to make sure that we don't create worse downstream consequences So in other words, the solution isn't worse than the problem. So I think we do need to do that. I think we need to look at racial and gender achievement gaps. And what I want to point out here too is that this summer everything really got turned up to 11 after the killing of George Floyd and Breonna Taylor, and I had friends that certainly had never heard of white fragility or anti-racism, reading those books and posting on social media that they were reading those books. So, but I guess my point here is that I had been thinking about this for a long time because, again, in the Twitter community that I was in the MTBOS, these ideas were popular. They were not new things. They've been talking about social justice and equity and those kinds of things for a long time. All right. Yeah, so I guess I already covered that. So let's keep going here. So if you've never heard of social justice math, it's a real thing. Go ahead and Google it at some point, and you will see that there's plenty of written about social justice math and how we can make mathematics class more oriented towards social justice. This is an answer to the context question. Right? This is I'm totally agree that we need to think about how what happens out there affects what happens in here. This is one answer, social justice mathematics. And the idea with social justice mathematics, just to give you a 10-second thing here, is just that you will think about teaching math through a justice lens. So you will focus on problems of climate change, economic inequality, racial inequities, those kinds of things. You will bring those into the math class. One problem that I noticed is that a lot of the social justice math stuff that I've read had some of the same problems as project-based math, where it felt like the math was getting minimized. And again, maybe I'm reading the wrong social justice math stuff, but I did notice that. I also worry that by calling what you're doing in class social justice mathematics, you're making what you do overtly political, and I think we need to be very careful with that. I don't. There's half the country is conservative, and so to say that you're teaching social justice math in your district or in your classroom seems disingenuous to a lot of people. Even if you mean just a focus on justice, just the words social justice have sort of a left-leaning connotation, for better or worse. If you're skeptical that this is even an issue, in Michigan, it's probably less so than in other states, but in Oregon, yes, just the other day, the Oregon Department of Ed put out a statement, put out not a statement, but a list of resources. One of them was a teacher training course where they talked about, part of the course talks about white supremacy culture infiltrating math classrooms and everyday teacher actions. They have another reference was essential actions from the movement to prioritize anti-racist mathematics, planning for this in every school year. Another part was who is brilliant here. This was a Desmos one, actually. What is brilliant here? Using student thinking and identity as the center of a classroom experience. So there's this hyper focus on identity as well. As I dug deeper on the ideas of diversity, equity, and inclusion, I noticed that some of the foundational beliefs from where these ideas come from were sort of illiberal, were sort of let me just give you a specific example. So like dividing people into either racist or anti-racist. So you can imagine, if you're not familiar with this stuff, how if you take a staff and you do sort of this exercise where you decide, well, all right, are you either racist or anti-racist? It sets up this us versus them mentality, which is inherent to conflict, right? An us versus them dynamic can be, I mean, it just lends itself to conflict and division. So that worries me. I worry about teacher training and diversity, equity, and inclusion training, and I just was trained the other day in a half-a-day session, and from what I've read, I worry that this isn't the best use of our time. I worry that there's other professional developments that we could do, especially focusing on like trauma and those kinds of things, trauma that our students have experienced and how to help students that have gone through trauma that would have more payoff down the road. I'm also, just to be clear again, I'm not arguing that there aren't problems, that there aren't inequities. I'm just arguing that to solve the inequities, to solve the problems, I'm not convinced that we need to turn the identity dial up to 10, that like this is how we're going to solve the problems is using these ideas. Yep, I already mentioned that. So, I want to talk very quickly, common humanity versus common enemy social justice. So these are two different types of social justice. Common humanity is, you might think of like the MLK version of, like in his I Have a Dream speech, where he talks about and being judged based on the content of your character, and we're all one people, and we've got more in common than what we have that are different, versus common enemy social justice, which is more, there are these bad people out here, let's find the bad people so that we can identify them and then explain to them why they're wrong, and if we can't explain to them why they're wrong, convince them why they're wrong, then we don't need to talk to them, we don't need to engage with them. Those are bad people. So I think common humanity, social justice is the way that we want to go. All right. Questions? All right, we're almost done. I promise, and we'll talk about critical thinking. All right, the truth between us. So I think I have the same goal as most social justice advocates, education advocates, and that is that we want students to go out into the world. We want them to see and understand problems that exist, injustices even, right? And we want them to be able to do something about them. Okay, and I think empowered students can do that. So let me define empowerment real quick. My definition is the process of supporting another person or persons to discover and claim personal power. And I think that we can do that by giving students the mathematical tools that can help them figure out what is true about the world and what is going on in the world. Sometimes you'll hear social justice education advocates talk about how math has been used for bad and has been used to oppress different populations throughout history. That is absolutely 100% true, right? But the tool is not bad. Like to say that math is a tool of white supremacy, that's not true. The tools in mathematics are powerful. They're power tools, right? And so we want to give those to students, and we want them to be able to use them effectively to understand what is going on in the world. There's this quote you may have heard by Audre Lorde that goes, "The master's tools will never dismantle the master's house." And I think this is actually 100% wrong. The master probably has the best tools. If the master has been using the tools to oppress people, then we need to get those tools into the hands of as many people as possible, especially those that have been oppressed over the years. So my theory is, let's get kids those tools as effectively and quickly as possible. All right, so we want our kids to identify problems in society. We want them to have the tools to understand what they are and how to do something about them. And then we want students to learn content that's relevant to their life. That's another thing you'll hear from social justice education, is that math education is too distant from students' cultures or their lives. Here's some things that I think are empowering. Having a toolkit for understanding the world, knowing and applying probabilistic reasoning, as we talked about, understanding when stats and charts are misleading, right? Understanding when someone in power is making a fallacious argument, that's empowering, right? Knowing what outcomes are predictable because of game theory, like understanding a system and understanding that these outcomes are predictable because of the way the system is set up, that's empowering. You're going to be able to identify injustices and systemic problems that, if you understand that. Understanding the math of networks is empowering. Understanding logic and computational reasoning, have a diverse set of lenses, understanding metacognition. All of these things are empowering. Understanding why freedom of speech is vital for thinking is empowering. Understanding the kind of information that emotion gives you and how it can lead you astray and how it can actually inform you is empowering. Understanding bias to confirm and those kinds of things. These are all empowering things, and they're all completely apolitical. We do not need to bring in politics to reach these aims. So our goals, if we are to reach our goals in my philosophy here, is we need three things. We need truth, which is figuring out what is true about the world. Ethics, which is what we should do about the world, about what is true. And courage, and that is having the guts to say something, to do something, and to be confident in what you think to make a change in the world, right? Even if it's a small change in your local community. And all of this needs to be encapsulated in wisdom, which is just making sure that you're not just, well, you guys probably all know what wisdom are. You're not, I probably don't need to explain that to you. So this is my model, this is my thinking, and I think that we can reach the goals of people that advocate for social justice education in this way. And I think we have a lot of overlap in our goals, but I think we can do it apolitically. All right, how I teach critical thinking. I'll pause for a second here. Are there any questions? Also, we're at about the halfway mark, and this is maybe not a session that you sort of expected, but I think actually math teachers, we really need to have conversations at this kind of higher level. These ideas are going to, they're going to show up in your schools and in your districts, and you need to understand them, and at some point you won't be able to just ignore them, because ideas like social justice math and those kinds of things, they're going to show up, they're going to come to your district. Now, some of them, for some of you, it's going to be a long time, right? Because if you teach in rural Michigan, you may never have any issues with it, but it's worth knowing and understanding anyway, I think. Especially if there's changes that are made at a bigger level, like the state level. That is not the right thing to click. Okay. Let's talk about how I teach critical thinking. This is my favorite part of the session. So I've got all this in my mind, right? I've got the 2016 election and what comes from that. I've got all of these other things that I'm noticing. I'm thinking about how students can apply their learning in mathematics. And so this is the course that I developed. It's my baby. It's the favorite thing I've done as an educator, and I'm just glad that I have a chance to share it with you. So here's how I teach critical thinking. It's broken up into 3 units. The first unit is thinking clearly. The second unit is reasoning. The third unit is identifying structure. Use your clicker, Zach. Come on. All right. Unit 1 is thinking clearly. And this is the least mathematical unit. This is where I bring in some of the psychology that I mentioned earlier. This was, so every 7 years, the math department gets to propose new courses and electives. And so being that it's an elective, I've got a lot more flexibility. So like I certainly took a psychology course in college and in education. You learn about psychology. I'm not an expert in psychology, but I can bring in some of these ideas because it's an elective and I have that flexibility. Here's a list of a bunch of stuff that we talk about. I'm not going to read all of these to you, I don't think. But the idea of this unit is figuring out and helping students understand their own mind and how it gets in the way of figuring out what is true. So we talk about metacognition, for example, which is thinking about your thinking. And I tell students, and this is, by the way, I had seniors last year in the class, all seniors and 1 junior, and they had never heard of metacognition, or if they'd heard of it, they didn't know they'd heard of it. And so this is, if you can think metacognitively, you can kind of introspect, right? And you can figure out like when you can pay attention to what you know and what you don't know. So just in like a basic math class, I talk about metacognition. It's like if you are metacognitive, good metacognitive thinker, you know when you don't understand something. You're never going to take a quiz and be like, oh my gosh, I thought I knew everything in the section, but then I did really bad on the quiz, because you'll constantly be checking in with yourself. We talk about listening and how to listen effectively. And it's a bunch of stuff from Daniel Kahneman's book, Thinking Fast and Slow. We do talk about base rates and how we're poor at probabilistic reasoning and understanding base rates. You can see we talk about how our memory kind of can lead us astray. All of this stuff is in the first unit, which is 3 weeks long. I should say that we're in trimesters. They're 12 weeks long. Unit 1 is 3 weeks, Unit 2 is 3 weeks, and Unit 3 is 6 weeks. So Unit 2 is the reasoning unit, and this is where things get more mathematical. This is where we talk about symbolic logic and formal logic and minding their P's and Q's and those kinds of things. We also have a day where we talk about how to fight fair. So again, it's an elective, and I'm thinking about how do we help students make sense of the world, and how do we help them have discussions that are productive. And so we do a lesson on how to argue in such a way that you, at least, at a minimum, learn something from each other. Even if you end up disagreeing at the end, can you find some overlap in your understanding and at least learn something from each other? We do have a thread in this unit on freedom of speech, and you might think, well, Zach, you just talked about how things are, how you shouldn't bring politics into the classroom, but I don't think freedom of speech is political. I think it is incredibly important, and especially for minority voices, because freedom of speech protects minority voices, and it protects everyone's speech. And so it's an incredibly important idea. We read an excerpt from On Liberty by John Stuart Mill that was created by Heterodox Academy. It makes that reading pretty accessible. We take the full 3 weeks to get through it, and we have some really good discussions about, do we protect the speech of speech that we don't like? What about hate speech? And those are, and the way it's sort of sprinkled in, right? So it's like, we might take the first 15 minutes of each day and kind of have a discussion about the reading from the previous day. And then we're on to the new stuff. So that's in there as well. We talk about tons of different logical fallacies. We talk about the fallacy of affirming the consequent ad hominem. We talk about argument from authority and ignorance. We talk about false dilemma. We talk about circular justification. We talk about the gambler's fallacy, all kinds of things, different types of logical fallacies. We talk about figuring out bias statements and arguments. And then we talk about creativity and reasoning. We talk about famous thought experiments. We talk about reasoning by analogy and how that can kind of help you make arguments and those kinds of things. So that's Unit 2. Again, you can see things getting more mathematical here. Any questions on the first 2 units? The third unit is the longer unit. All right. Unit 3 is identifying structure. And so in this unit, we start off by talking about reasoning with probability and statistics. And we talk about basic probability. We start off just talking about figuring out the probability something is going to happen is a number of ways it can happen divided by the total number of possible outcomes. And we talk about sneaky probability, which is where, I don't know, we talk about the lottery. We talk about ways that people use probability for rent seeking, for tricking people. And so we talk about that. We talk about visualizing probability. We talk about day-to-day statistics. So we talk about here's the statistics that, like, the statistical knowledge that can help you in your day-to-day life, literally from the grocery store to home to the internet or whatever. We talk about statistical reasoning and research. So we talk about the difference between univariate and multivariate data. So if you're doing a data analysis and you're only doing a univariate analysis, you are going to miss out if you don't consider the fact that it might be a multivariate situation. We talk about sampling, sample size, randomness. We talk about base rates in this unit as well as in Unit 1. And we talk about p-value, which is something I've never seen in a math textbook, although that's not entirely true. I think it was in our pre-calc book. Maybe it's in other Algebra 2 books, and I just missed it. But we talk about p-values, and we talk about p-hacking, which is a really interesting concept that is talking about statistical significance. How do we decide whether the conclusions or the research that we're doing is statistically significant or not? And a lot turns on that, right? Because you will read about papers, especially in the news, where they say that the data was statistically significant or it wasn't. And so understanding that is powerful. We talk about the replication crisis in psychology, behavioral psychology especially. We talk about it in education. I didn't talk about this much earlier, but part of the replication crisis is, when I talk about it with students, as I explain what replication is and why it's important in science, and then how there are 2 problems: studies that don't replicate, and then not attempting to replicate results. Those 2 things in combination are combined to give you the replication crisis. Also, this is where we talk about game theory, and this is one of my favorite concepts, and the students really enjoyed this too. We talk about trust and reciprocity, and how you can set up systems. So how a system set up on trust is obviously superior to one that isn't, and this concept of reciprocity, which is really just the golden rule, right? Do unto others as you would have done unto you, and how that is how that can lead to a moral society. We talk about the prisoner's dilemma, evolutionary. I don't need to read all of these to you. So I'll just try to pick out some that you've maybe heard of. Race to the bottom, you've probably heard of. Free rider problems, tragedy of the commons. We talk about zero-sum games versus non-zero-sum games, which I think is a really important concept. Principal agent problems. Let's talk about that briefly. A principal agent problem is any situation where there's a principal, which is someone that has some sort of control, and an agent who is sort of at their control. So for instance, when I take my car to the mechanic, I'm the agent, they're the principal, and I'm at the mercy of their expertise and their good faith and their honesty or lack of honesty. So in those situations, there's a power differential, right, or a competence differential, a knowledge differential. That's a principal agent problem. So we talk about empowering students, and we talk about justice, right? Being able to identify when you're in a principal agent situation and how you can best mitigate and hedge against being taken advantage of those situations. Super empowering, and again, I think apolitical. We talk about the law of diminishing returns and negative returns and those kinds of things. Yeah, all right, so let's keep going here. we talk about graph theory, and I didn't do a fantastic job of helping students understand how this was applicable. We do some sort of fun activities that I don't know if David's on the call or not, but that some of the activities I took from him at a PD that we did up at Michigan Tech, actually. But I think graph theory is more interesting than what they do, probably. But like graph theory is where the four-color theorem comes from, that you can color a map with no more than 4 colors are required to color a map. We talk about vertex coloring, which is the map example. We talk about cycles. We talk about spanning trees. And in general, we're just thinking in terms of networks here and understanding networks. And I need to do a better job this year of helping students apply this to their world, right? Make it more useful for them. There's some features of critical thinking that I'm really excited about, and maybe the best parts of the course. Mental Model Mondays is one. Here's a few mental models that we've talked about. So a mental model is just a way for understanding, a way for looking at the world that can be useful or has been useful for other people. The map is not the territory is the first one, right? So this idea that a map inherently loses information when you create a map, right? So a map of Michigan loses a lot of information. So you have to remember that if you're following a map, you're not getting the map of the entire territory. Some information has been reduced, and you might think, well, who cares? Everyone knows that about a map, but a map can be something more general, so it can be like an economic model, for example, right? So, or other scientific model where if that's your map, you have to pay attention to make sure that your map is tracking the territory, and when it's not, you need to probably be metacognitive and pay attention to that and change course. Anti-fragility, which is this idea, and this is a super powerful idea for students, I think. It's that there are some systems that are fragile, like a glass, like my mug. If I throw this off the ground, it will break, it will shatter, it's fragile. And there are some things that are anti-fragile. The second one is things that are strong, that are, so like a piece of steel is very like resilient, right? But it doesn't, it's not anti-fragile, because if it was anti-fragile, it would grow from from distress. It would grow and become stronger from being exposed to, for lack of a better word, because I can't think of a better word, bad things. Okay, so for instance, your immune system is anti-fragile, right? If it's never exposed to pathogens, then it won't get better, and you will end up with a very weak immune system. So, and it turns out that people are anti-fragile systems as well. What doesn't kill you makes you stronger is obviously not literally true, but metaphorically at some level that is true. So things that, slight discomforts and those kinds of things, and if you can overcome them, can result in you becoming stronger. We talk about compounding, the importance of compounding. We talk about first principles thinking. Hanlon's razor. Hanlon's razor is the idea that it's never attribute to malice that which can be attributed to incompetence or ignorance. And we also talk about telling the truth and how important it is, how important honesty is in understanding what the heck is going on in the world, and how you want to be the kind of person that people can rely on to tell the truth and correct you when you're wrong or when you're off in some way. We also have Thinking Tools Thursdays. Thinking Tools Thursdays is, I took a bunch of thinking tools from Daniel Dennett, who's a philosopher, from his book Intuition Pumps and Other Tools for Thinking. Some of them are making mistakes, which is just, I didn't know what I was going to get when I read this book, and the first thinking tool he talks about is making mistakes, and that's something that, so that's what we start off with. The first week for our first thinking tool is making mistakes and how important that is for learning, and I think at some level it's like, all right, look, there's this philosopher he's a famous philosopher, and he starts off his book by saying how important making mistakes are. Some of you put in the survey that, something about making mistakes in mathematics and how that's valuable, and so we make that explicit right at the beginning. He's got a bunch of other ideas and thinking tools too. I mentioned this, the free speech. This is a book by John Stuart Mill. Well, it's a chapter from a book that the group or the organization Heterodox Academy put together, and there's some kind of striking images in it, and it makes it very, very accessible to students. Okay, so I'm going to give you some resources now and kind of talk about the resources that I have. I did a little bit better on time than I thought I would. So are there any questions at this point or anything that you're wondering about before I sort of explain what what I've got to share with you here? Yeah. So how do I see it relating to social justice and or diversity? Well, I think I'll take the social justice piece because diversity is so is maybe a little bit more ill-defined. But for social justice, you know, as I sort of mentioned, I think that these. So if you want to create justice, right, you need to understand the situation. You need to understand what the facts are. You need to understand the systems that have led to whatever the situation is, whatever the inequity is, or whatever you're analyzing. And if you can understand those things, and so that's the truth component, right? And then you think about, okay, well, so what should we do? And you have the tools to understand what's going on, and then you have the courage to do it. I think you will end up with students that will go out into the world and will find injustices and set out to remedy them, right? To fix them, and so that they don't happen again. And so I think, as I've tried to make the case here, that there's some mathematical tools, or maybe a lot of mathematical tools, or mathematical thinking that can help students do that. So, you know, when it comes to diversity, you know, I guess I would ask you to kind of define exactly what you mean by diversity. So I'm a huge proponent of viewpoint diversity. That's one thing that we talk about in class. We had wide viewpoints within, you know, from our students, which is to be expected. And especially in the freedom of speech conversations that we had, we talk about how our viewpoints can become stronger by being exposed to different viewpoints. I'm skeptical of the superficial level of diversity, where we are just looking at skin color and kind of or gender and just sort of counting based on that. But yeah, I don't know. Does that answer your question? Okay. All right. Yeah. And I'd happy to talk about it more later. So, all right. Here's some resources for you. So like I said at the beginning, my hope was that either the whole course or pieces of the course could be exported. And had COVID not happened, then I would have had a lot more time to refine some of this stuff and put it in a shareable format. But here's some of the things that I've got for you. I've got the unit plans. So the unit plans are the best way to get an idea of what I do in the class on a day-to-day basis, and links to all the lessons and slideshows and those kinds of things. So those are all linked there. The weekly features, the Mental Model Mondays and the Thinking Tool Thursdays, those are all just Google slideshows that you can kind of steal. And again, you know, if it's something where you could do Mental Model Monday. These take anywhere from 10 to, well, you can go a long time actually, depending on the conversation. But some of them take 5 to 10 minutes, and just exposing students to these ideas. The same thing with Thinking Tools. So those are there as well. I tried to go through each unit and pick out the best resources that I had from each unit. So my lesson on listening and my lesson on metacognition are linked there. Again, just slideshows, and those are I had students after the first week. I kind of asked them a poll, and they said that these were really interesting ideas. They were really glad they learned about them. They hadn't heard about them before, and I should, I guess, pause. And I'm not trying to brag here, but I had a few students say that this was the best class that they had taken, that they had learned things that they'd never been exposed to before, and so at the end of it, I really did feel like I was sort of onto something, and that some of these ideas the students really appreciated kind of being exposed to and understanding. I also, this height-or-symbol illusion, I'm going to show you in just a second here, but the final project, we have a final project at the end of each marking period. Those guidelines are linked there. I have my How to Fight Fair lesson. I have the all -1 lesson outline for the freedom of speech stuff, and then the logical fallacy slides in that lesson as well. So you could kind of pick from this if you'd like. The height-or-symbol illusion is really interesting, and I think we got 9:50. Yeah, I think we've got time. I'll just sort of talk over it. But we have, I have students watch this video. We don't need sound, I don't think. we have students watch this video, and in this video, what you can see is all you have is shapes and, all you have is triangles, a circle, and lines, right? But as you watch, you can see that you start to subconsciously attribute behavior and intentions, and you impose a story on this, this animation here. And I use this to show students that we are wired for story at some level, and that can lead us either understanding that can lead us astray sometimes. So this one clear example of this is correlation versus causation, right? Where you see data points or you see a connection between things, and then you create the story for those two things, whether there is actually a connection between them or not. So that lesson is in there as well. Let's see. Other stuff that I've linked here, my day-to-day probability lesson, statistics, statistical significance lesson, the p-hacking activity. This is, you've probably heard of Nate Silver, who is, I think he was the founder of the 538 website, and his 538 put together this animation, not animation, interactive website, I guess you'd say, where you can figure out, you can try to show that one party is better for the economy than another party. So for instance, if you want to look at just employment, you can turn on the presidents, governors, senators, representatives, or turn them off, and you can kind of basically turn all the knobs and see how to get that p-value below 5. And what you find is that you can, depending on the story you want to tell, you can either show that the Democrats are better for the economy, or you can show that the Republicans are better for the economy. So it's sort of an interesting interactive activity that's linked there. The evolution of trust activity, to talk about in a second, I think. Yeah, so this is an activity that, we're at 9:53. I don't have a ton of time to explain it. It's, but it's sort of a fun activity to kind of, where they talk about cooperation. It's my lead into game theory. It's just sort of an interesting interactive activity. And then my interactive graph theory, the introduction that I have for graph theory is there as well. So this is a great activity just to expose students to the idea of graph theory. It's very low floor, high ceiling, and if you kind of play around with that, you'll see what I mean. So that's there as well. Other resources and references. So again, sort of zooming out here, I put a bunch of links that you can kind of look at for the ideas that I've talked about, especially related to viewpoint diversity and social justice education and those kinds of things. Those are all here. The one that I really wanted to emphasize is this article here called Teaching Empowerment. And so this article, actually my friend wrote it from Heterodox Academy, and she lays out 3 different models for teaching empowerment to students, even different than what I've talked about here. She talks about the theory of enchantment, which is Corey Valdery's ideas, moral courage, which is Irshad Manji's ideas, and the empowerment framework, which is Eric Smith's ideas. That article is a 5-minute read maybe, and is really interesting. You'll be exposed to some really fantastic thinkers. Chloe, Irshad, and Eric are really interesting folks in this space. So I have a quote from the article. I don't really have time to read it, but anyway, it is a really interesting article, so hopefully you'll take time to read it. Here are all my references and resources that I use for teaching the class. So these are all just, you can see some of the books that I've referenced here, but there's, those are just there if you want them. They're all hyperlinked. I have to give a shout out to Heterodox Academy. They are a nonprofit, nonpartisan organization that is trying to spread viewpoint diversity. They started off emphasizing viewpoint diversity in higher education, and they've since moved to K-12 and other areas of facets of education. And they have a K-12 education Facebook group, which I'm a part of, and then we have a very, very young Discord server as well. But the Facebook group is, I encourage you to join that if you're curious about these ideas and viewpoint diversity in K-12 education. Okay, and that brings us to the end. I feel like I've glossed over some things because when I was practicing, it always took longer than this. But I just want to thank you guys for coming. I don't know. I didn't look at how many people were on at the beginning or how many people logged off, but I appreciate you all sticking around. I know this probably wasn't something. These ideas were probably not something you maybe expected, And if it wasn't as applicable to, teaching synthetic division on Tuesday, I apologize. There's some great sessions later on that I think will focus more on that. But I do think that it is important to have these sort of these kinds of discussions about these ideas, because I think they're valuable. Obviously, I guess that's why I just talked for an hour about them.